Hello everyone. This is a special video on region-based segmentation. We have already studied the different types of segmentation based upon discontinuities, like point detection, edge detection, line detection. We can use a high-pass filtering mask to detect the point, to detect a line, and we can use edge linking techniques by using Huff transform or a graph theoretic method is also known as global processing. Now, this is a different kind of segmentation that we are going to study is a region-based segmentation. This is totally based upon the similarities. Suppose you have the input image which has a region R. Now, the R can be divided into multiple regions like R1, R2, R3, R4, and R5. Each and every region they are sharing some similarities, and you divide the entire region based upon the similarities. Okay, now the similarities, to detect the similarities you need to set a condition, the condition that you need to satisfy, then only you can relate each pixel with that particular pixel. Okay, now there are four types of region based segmentation: region growing, region merging, region splitting, region split and merge. Okay, now we are going to study the first type, that is the region growing. Now suppose in examination you will get the input image like this, and you to divide the region into multiple regions. Now you need to consider the highest intensity value in the image and the lowest intensity value in the image. Now 7 is the highest intensity value and 0 is the lowest intensity value. If I divide 7 by 2, if I want to have half portion of 7, that will be the 3.5. I cannot select the decimal point version of your intensity value or threshold value. So I will go for the nearest one, that is a 6. If I divide 6 by 3, sorry 6 by 2, I will get the 3. I can set the threshold value, that will be the average between your 0 and 6. Okay. Maybe if you don't get any seed pixel in the examination, you need to select the seed pixel. You can select any seed pixel, whatever you want to have in your region growing based problem. Okay. Now suppose, and then you need to decide the connectivity, that is 4-point connectivity. If you're considering 6 as a target pixel, you need to consider the 4-point connectivity. 7, 7, 4, 5, these are the 4-point connectivity, that is above, below, left hand side, right hand side. Then you need to consider the diagonal connectivity, 7, 4, 7, 5, and when you union this, the union of 4-point connectivity and diagonal connectivity will be the 8-point connectivity. Okay, and you need to satisfy the condition, that is maximum intensity value minus minimum intensity value less than threshold. It is not actually the intensity value, it should be the seed pixel value. Okay, now how do we do it? Now suppose, uh, if in the examination you will be given with a seed pixel value 5 and 1 and the threshold value is 2. Now I can select any of the 5 intensity value from any location of an input image. I can select any 5, and they have given you need to select one more seed pixel, that is 1. Again I can select any one from the input image. Okay, now suppose I am selecting a 5 at the coordinates of your input image 1 and 2. So I need to specify that I am selecting f of 1 2, f of 1 2 as a seed pixel which has intensity value 5, and I am selecting 9 4. The 9 4 is a coordinate, 9 4 is a location for the pixel number 1, or pixel who have the intensity value 1. Now I need to specify the seed pixel coordinates. Now I need to I need to calculate the predicate. Now predicate will be the modulus of f of xy minus f of x dash and y dash. F of x dash and y dash will be the seed pixel or the coordinates of your seed pixel, and f of xy is your input intensity value. Now I need to calculate for each and every intensity value. I need to subtract the seed pixel value from each and every input intensity value, and I will calculate the predicate. Now suppose I'm considering the 4-point connectivity of these five. Now five has an different types of a neighbor, like 4 4 5 7 5 6 7 6. I need to put the f of xy as a 4 4 5 7 6 5, and I need to calculate the condition. Now suppose I'm considering the 4 as a f of xy. 4 minus 5 will be minus 1 because of the modulus only. You need to consider the non-negative value. So 4 minus 1, 5 is minus 1. That will be the 1 because of the modulus, which is less than or equal to 2. So you will mark 4 as a. Then you will select the another pixel f of xy, that will be the neighborhood. So 7 minus 5 is 2, which is less than or equal to 2. Again, you will mark all 7 as a region. Okay, you need to denote all the 7 as a. Again, then you will go for 5 minus 5 is 0. Yes, you are satisfying the condition, that is less than or equal to 2. You will mark all 5 as a region. Then you will go for now you are done with the 4. Now you will go for 6. 6 minus 5 is 1, that is less than or equal to 2. So you will mark all 6 as a. Then you will go for the remaining pixel. They are nothing but 3 2 1 0 3. Now 3 minus 5 is minus 2. Minus 2 because of the modulus will be 2, that is equal to 2. You are satisfying the condition, you will mark 3. Now if you look at in this problem, if you calculate for seed pixel value 1 and seed value 5, in both the region 3 is sharing the similarities. Okay, okay, you will be able to understand. Now I will keep 3 as a blank. In this output image I have shaded with a different color. The 3 location is being shaded with a different color, and I will tell you how to actually locate or how to actually denote the 3 region as A or B. Okay, now 7, now pixel value 7 6 5 7 3, whatever the pixel value I will put in a f of xy, I will be able to satisfy the condition, that will be the region A for the seed pixel value 5. Now I need to consider now 7 6 5 4 3, what will be about 2 1 0. So if I set 2 minus 5, that will be the minus 3, which is not satisfying the condition for less than or equal to 2. You won't be able to include your 2 intensity value in a region A. Similarly for 1 1 minus 5 will be minus 4, that will be 4, which is greater than 2. You are not able to satisfy the condition. Similarly 0 0 minus 5 will be minus 5, that will be the 5, which is greater than 2. Okay, you won't be able to satisfy the condition. So for 1 0 and 2, you cannot include them in a region A. But if we calculate for the region or another region or for another seed pixel, the possibilities of intensity value that you can satisfy the seed pixel for the seed pixel 1 will be 3 2 1 0. If I put 2 minus 1, that will be the 1, which is less than 2, less than or equal to 2. I will consider all 2 as B region. Okay, if I put 1 1 minus 1 is 0, which is less than or equal to 2, so I will denote all 1 as B region. Everywhere I will put 1 as a B. If I put 0 0 minus 1 will be minus 1 because of the modulus will be 1, 1 is less than or equal to 2, that is why you are satisfying the condition. You will denote all 0 as B region. Okay, and if you put 3 3 minus 1 is 2, yes, you are satisfying the condition. Now in this problem you will be able to uh, understand that the 3 sharing in region B as well as in region A, means 3 sharing similarities in region B as well as in region A. Now how to denote a region A and how to denote region B for intensity value 3. Now I have shaded the location of the 3 pixel by the different color. For example, if I consider A as country like India, and B is a country Australia. Now suppose if I'm living in India, I will get a citizenship of India. Okay, so if you are in A region, if your 3 is in A region, you will consider 3 as A. If you are in Australia, you will get a citizenship of Australia. Similarly, if 3 is in the B region or the country called as B, you need to get the citizenship of that particular country. Means if you are whatever the area you are residing in, you will denote that area as your identity. So I will denote these 3 pixel as A and these 3 pixels are as B. Okay, and I can have an output like this. So I have two separate regions, region A and region B. Okay, so I have divided my entire R region into R1 and R2, whatever the name you want to give. Now the both, if the pixels of the B region, now if you compare the all the pixel value, they are satisfying the condition for the seed pixel 1, and all the pixel value in A region, they are satisfying the condition for seed pixel 5. So you can say the seed pixel 5, all the pixel values in this A region is related to seed value 5. All these pixel value or intensity value in B region are related to seed pixel value 1. And by the relation only, you can actually divide your region into multiple region. This is known as region growing based upon similarities, or region segmentation based upon similarities. You are sharing the similarities, that is seed pixel 5, you are sharing the similarity, that is seed pixel 1. Okay, now next type is a region splitting. You need to split the region. Now remember, in a region splitting, you need to split the region in 4 equal parts. You need to consider the number of rows and number of columns in order to split into 4 by 4. 4 by 4 is mandatory, because if you don't find any similarities in 4 by 4, you can go for 2 by 2 and up to 1 by 1, means up to single box or single cell you can go uh, for the splitting. Now what is the condition, or what are the steps? If the gray labels present in the one region and do not satisfy homogeneous property, then region will be divided into 4 equal parts. Okay, now quadrants will not satisfy homogeneous property, then again split into 4 parts. Means unless you get a similarities, you will split a region into 4 parts. Okay, how? Now suppose now first, now what is maximum pixel? The maximum pixel is 7 and a minimum pixel is 0. 7 minus 0, 7 minus 0 will be 7, and if you have the threshold value 3, now in this image you have a threshold value 3, you need to satisfy the condition that maximum intensity value minus minimum intensity value should be less than or equal to 3. If you won't be able to satisfy the condition, then you need to divide your region into 4 parts. Okay, in this input image, the maximum value is 7 and the minimum value is 0. 7 minus 0 is 7. You are not able to satisfy the condition for the threshold value 3. So you will divide the entire region into 4 parts. Okay, and you need to remember, you need to consider 4 by 4, 8 by 8, 16 by 16 partition, 32 by 32 partition. If you go with that manner, then only you will be able to achieve the splitting of the region up to a single unit cell. Okay, remember this. Now I have 4 columns, 4 rows in the means in every region I can find four rows and 4 columns, so I can go up to 1, because if I will find any irregularities in the image, I can again divide this 4 by 4 into 2 by 2. If again I find any irregularities or non-similarities, I can divide the 2 by 2 into 1 by 1. That will be the single cell. Okay, and I can have the splitting of the region. Now I will actually give a naming to each and every region. Suppose I have splitted my region into four parts. R1 will be the region, that it will be the first region, R2 is the second region, R3 is the third region, R4 is the fourth region. Okay. Now what is the maximum value? You need to consider each and every region. Maximum value for the R1 is 7. 7 minus minimum value is 4. So 3, yes, you are satisfying. I mean, you have satisfied the condition. Okay. So yes, thumbs up. For R2 region, what is a maximum value? 7 and the minimum value is 0. 7 minus 0, that is a 7. No, you cannot satisfy the condition. Now R3, this is the region. What is the maximum value in this region? 3 minus 0 is 3. Yes, satisfied. Now for R4, what is the maximum value? 7 and the minimum value is 1. 7 minus 1, no, you cannot satisfy the condition. So whatever the region that you cannot satisfy the condition, in that region you need to split the region into again four parts. Okay, so next step will be R2 and R4 I need to split into four parts. Okay, R2 and R4. I will not split R1 and R3 because they have satisfied the condition. So next step will be I need to split R2 and R4 into four parts again. Okay, that will be the splitting. Now I have splitted my R2. Now I will get a four extra new regions. R21, then R22, R23, R24, R41, R42, R43, and R44. Same. Okay, R1, R3 I don't have to split because they are satisfying the condition. Now again I will go from each and every region. I have already satisfied the region R1, R3, they are satisfying the condition. I don't need to do the calculation again for R1 and R3. I will go for R21, R22, R23, R24. Okay, so R21, what is the maximum pixel? 5 minus and minimum 4. 5 minus 4 is 1. Yes, you are satisfying. Similarly for R22, 7 minus 5 is 2. 7 minus 5 is 2. For R23, 7 minus 0, no, you cannot satisfy the condition. For R24, you have maximum 7, minimum 4. 7 minus 4 is 3. Yes, you have satisfied the condition. Now you have R41, R41, R42, R43, R44. Now R4 has been divided into four different parts. So R41, maximum pixel is 3, minimum pixel is 2. 3 minus 2 is 2. Yes, you are satisfying the condition. Then maximum 7 minus 5, 2. Yes. Then you have 7 minus 2, no. R43 do not satisfy the condition. Now R44, 6 minus 4, 6 minus 4, you are able to satisfy the condition. Now in this image again R23 and R43, they are not satisfying the condition. Again you will go for four part splitting. So that will be the another step. So that will be the final value up to the final splitting into one single unit cell you need to go. So now you have R1, R3, okay, R2. The R2 has been divided into four parts, and out of all the four parts, again you have divided the third part of R2, that is R23, into four parts. So R21, R23, sorry, R21, R22, R23 is divided into again four parts: R231, R232, R233, R234, and R24. Okay. Similarly, R4 is divided into four parts: that's R41, R42, R43, R44. But R43 was showing some discontinuities or non-regularities. So you have divided your R43 into four parts. So R431, R432, R433, and R434. And you need to draw a graph that you have entire R region. You have divided first you R into four parts: R1, R2, R3, R4. Now out of uh, R1 and R3, they are showing similarities. You don't have to divide the R1 and R3 region. You have divided then R2 and R4 into R21, R22, R23, R24, R41, R42, R43, and R44. Now 2, 3, and 4, 3 were showing again irregularities in the image. Again, they were not satisfying the condition for the threshold value R43 and R23. Again, you proceeded with this again splitting in the four parts. So you have R231, R2, R232, R233, R234. Similarly for R43, R431, R432, R433, and R434. That is image region splitting in image processing. Okay. Now the next type is region merging. Now in region merging again, you need to satisfy the condition like now. Here you need to satisfy the condition in both the direction. You need to consider the region and adjacent regions, and you will satisfy the condition. How to do the region merging? Suppose you have the input image. In the examination you may get the splitted version of your input image, or if you have the input image they will ask you to split the region and then merge. Okay. Now suppose you have the input image like this. You need to satisfy the condition, that is maximum g of xy of one region minus minimum g of xy of adjacent region. Suppose this is the region, this 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 is adjacent region to this region, this is the adjacent region to this region. If you're considering this region is adjacent, this region is adjacent, this region is adjacent. You cannot consider diagonally connected area. You need to consider the adjacent region. Now how to do it? Now suppose, sorry, if I consider this, what is the threshold value? The threshold value is 3. You need to satisfy the condition. Means if you consider the maximum pixel of this region, if you consider the maximum, if you're considering this region and this region for the condition, if you will select maximum pixel from this region minus minimum pixel from this region, if you are able to satisfy the condition in that, you will open the region. Now before opening you need to satisfy in reverse order the maximum input pixel or maximum intensity value of this region minus minimum intensity value of this region. How? Now we need to satisfy the condition for the threshold value 3. Okay. Suppose you have the input image like this. Now, what is the maximum intensity value for this region? I need to consider the adjacent region is this. Now maximum input value or maximum intensity value is 7, and the minimum intensity value for the adjacent region is 5. 7 minus 5 is 2. Yes, you are satisfying the condition, that is less than or equal to 3. The threshold we have set is 3. Okay. Now this is the one direction. Now you need to consider in another direction, from this direction to this direction, this region to this region. What is the maximum? 7. And what is the minimum intensity value? 4. 7 minus 4 is 3. Yes, you are able to satisfy the condition. You can open the edge, you can open the boundary, and you have merged this region with this region. Now you have a merged version of this region and this region. Now you have entire region, you can compare this region with this region, this region. Now what is maximum? 7 minus minimum 4, 3. Yes, you are satisfying the condition in this direction from reverse order. Maximum is 7, minimum is 4, minimum is 4. 7 minus 4 is 3. Yes, you are satisfying the condition. I will open up this edge. Okay. Now maximum pixel value is 7, minimum pixel value is 4. 7 minus 4 is 3. Yes, satisfied. Then maximum 6, minus 4 is the minimum. 6 minus 4 is 2. Yes, satisfied. Similarly for this region and this region, maximum is 7. 7 minus 2 is 5. In any direction, if you won't be able to satisfy the condition, you cannot proceed to open the edge. Okay, you cannot open the edge, you cannot open the boundary, you cannot merge the image in between. So yeah, we will go for the next regions, this region and this region, this adjacent region. You cannot satisfy for this and this region. I will go for these regions. So maximum is 7 minus 4. 7 minus 4 is 3. Yes, satisfied. Now 7 minus minimum value is 4. Yes, satisfied. Open the edge. Now you have merged up to this. Now before you were having the splitted version, now you have up to this. Again, what is the maximum? 7 minus 4, 3. Yes, 7 minus 4 is 3. Maximum is 4 and maximum is 5 and minimum is 4. 5 minus 4 is 3. Sorry, 5 minus 4 is 1. Yes, you have satisfied the condition. I have opened up. Now satisfy this condition. Now, maximum is 7, minimum is 0. 7 minus 0 is 7. No, cannot satisfy. Okay. Now, as I cannot satisfy the condition and cannot satisfy condition for the 4, 5, 6, 7 and minimum value 2, 3. No, I will go for this region. Now, maximum is 3, minimum is 2, 3 minus 2 is 1. Now, for this region, this is the one direction, another direction will be from this to this region. Maximum is 3, minimum is 2. Yes, I can satisfy. I will open. Now, here, maximum is 3, minimum is 0, 3 minus 0, 3. Yes, it is satisfied. Again, maximum is 3, minimum is 2, 3 minus 2 is 1. Yes, it is satisfied. Open. Now, maximum is 3 minus 0, 3 minus 0 is 3. Yes, and then maximum is 3, 3 minus 0 is 3. Yes, so I can open this region. Now, this is the region merging, and this is the output after when you merge all region based upon the similarities, based upon the threshold value condition. Okay,